Alright guys, welcome back. In this video we're going to talk about the spindle for the mini CNC router. As you can see, I got it about 90% done. Have it mounted on the machine. There's some things definitely I wanted to talk about as far as sort of designing but also machining this. Alright, so the first thing about the spindle was, obviously this is probably the most complex thing about the whole mill. Probably the biggest thing was trying to keep the bore for this deep groove ball bearing and the bore for the two angular contact bearings, keeping that, concentric, whatever, true to each other. It turned out very well. I did that in a 4-jaw chuck on the lathe. I really don't show any videos of machining and that kind of stuff, because there's enough videos and channels about machining. My channel is sort of more about, design aspects, problems you run into, solutions to that kind of stuff, and just basically to give people ideas and, maybe sort of think about things in a different way whenever you're building something, designing something, making something, whatever. I try to keep my designs very simple, strictly for the fact that the easier it is, the simpler it is, most likely, the less I'm going to mess it up, the less problems I'm going to have with it. So I'm going to pull this off here and we'll sort of talk about it and some of the issues I ran into with machining this and putting it together and everything. Alright, so the design of this guy was pretty straightforward. We have a bore up here. I have 4 M5 threaded holes. That's just to put a plate to support the motor. At the top here, it's basically just a little piece I machined with some grooves for some O-rings to act as belts. Just did pockets in them. Now underneath here, this was probably one of the most challenging pieces, just due to the fact that, the way I designed this, inside of here is actually a groove going the whole way around, and it's to fit an O-ring. You'll notice by the little grub screw on the side here, I actually initially had this filled with oil. Well, it held, sitting there, even spinning a little bit, didn't leak anything. But over the period of 2 or 3 days, it just all seeped out. I'm not sure whether, the O-ring just isn't going to seal. Maybe it got torn a little bit. Sort of what I learned and what I researched is whenever you do use an O-ring for a seal like that, you just want it barely touched. Like, you don't want it compressed. The natural shape of it is what you want touching, the rotating end of it. As far as the outside, you actually want the groove where it would sit to be sort of right on size, maybe slightly smaller, so it sort of grips the side of the O-ring and keeps it from spinning around, obviously. So, long story short, it actually does hold on. If you put oil in it and hold it there for, maybe 8 hours or something, it will hold it, but then after that it sort of seeps through. So right now there's grease in it. Probably the other biggest thing, challenge I ran into with this is just an ER11 extension shank, I guess is what it is, but obviously it's hardened. So that sort of, it gave me an issue as far as trying to keep it staying in here, right? You can't just like slide up to the bearings and hoping it's going to stay in there. So my solution was I actually tapped, there was a hole in the center of it, I actually tapped it with just a high-speed steel tap. So I'm not sure if these are just case hardened or just not that hard, whatever the case may be. I was able to tap it for an M7x1 thread. It was actually kind of a rare thread, at least from what I've seen, at least trying to find bolts. So I just got a real long bolt, Loctited it, screwed it in there, cut it off to the length I needed, and that way I have a way of attaching nuts, and everything sort of squeezes together on the bearings. Holds it all in there. It isn't coming out of there. I ground the flat just for the set screw. Okay. That way, you know, this guy isn't going to spin on there. I wasn't relying just on, you know, the friction of having it torqued down. Now, as far as the angular contact bearings, the way that I preloaded them was just with brass shim stock. What I found on these, not that it, you know, it matters because every bearing is different, but it was roughly, I needed a 10,000ths shim around there, so that when the inside races of both of them were compressed completely together with a 10,000 distance for the outside of them, it gives me just very light preload on it. You know, I can spin this fairly easily. I wanted, you know, obviously you don't want them over torqued or too much preload. I mean, you don't want them under, you know, you don't want to have not enough preload, because then you'll have play and, you know, all that. These bearings were cheap. They were like, I think $20 for two. I can feel, because there is a rough spot going around, and I clean these very well. I mean, parts cleaner, I, you know, blew them out with air several times. It seems to be getting a little bit smoother, but I can still feel there's a few rough spots. You know, it could have just been damage in shipping. I sort of, you know, everything should be hardened, so I sort of doubt that. But as far as dirt, anything like that, I'm very meticulous about stuff like that. Like I said, I did test the brushless DC motor with this, and I sort of talked about in the last video, you need to run them pretty much to the full voltage, pretty close to that. That's where they have their most power and most torque. I wasn't sure with them motors, being that they basically are a mini, you know, three-phase motor. I thought maybe, you know, a little bit less than half voltage, it would just give me less speed, but the equivalent amount of torque. No, not with these guys. I found when I ran it at 5 volts for that motor that it barely, I mean, it couldn't even turn this. Whenever I put 12, it would turn it, but it was real. I mean, the motor was heating up, the ESC was heating up. It just did not have enough, you know, power to do it. But overall, I'm very happy with this. Just the fact that I got that bore and the bore that's inside of here, you know, in line, I'm totally amazed with myself. Just a lot of time, you know, with the indicator, you know. What else? There was something else. Oh, one of these, I actually broke a tap, because I initially tapped them for an M3 by 0.5, sort of, you know, these little ones that are on everything else. And I'll tell you what, that I've broken 2 of them taps. Luckily, the one was in a non-critical area, and it broke about halfway down. How I end up getting that out with just there's a Dremel tool with a carbide burr bit, you know, like the little smallest pointy one, and I just took my time, and you know, I was able to dig it out and blow it out of there completely. And then I just tapped them for an M4, which was a lot easier, and you know, it's a little bit of a bigger thread. But other than that, guys, that's sort of how I designed this one. I know a lot of people that I've seen do this, they sort of mount the motor right on top. I think that looks cool, and I would like to do that, but yet again, I wasn't sure about, you know, basically the pulley ratio between the spindle and the motor, and I would like it variable. So if I decide I want to make it, you know, spin a little bit faster or spin a little bit slower, I can change the ratio instead of just going, you know, if you have the motor coupled directly to the shaft, you're limited to, you know, the max speed of the motor itself. As far as, you know, if you have pulleys, you know, obviously you could do a bigger pulley on the motor and get a little bit more top speed. Obviously you're going to lose torque, but that's a whole different video, I guess, talking about that kind of stuff. But anyways, guys, you know, I was very glad how this turned out, and hopefully the next video it's going to be with the motor on there. Once I get it figured out, I will let you know of any issues that I run into as far as stuff with that, and hopefully we'll at least be able to do some test cuts in the next video. Again, you know, if you guys like this video, if you have any questions, anything like that, leave me a comment. I encourage you to subscribe, because after this guy's done, we're going to be moving on to the big CNC mill, and there's definitely going to be a lot of stuff to go over in him, because there's going to be some pretty expensive parts going on that, but you know, I want that thing to be like top of the line. Anyways, guys, thanks for watching.